Hello, everybody. Welcome to Powering Dynamic UI with Viewmodels. My name is James Allman, and I'm a lead tech UI designer at Epic Games working on Fortnite. I'm extra excited to be here in Orlando today because I'm actually a graduate from the local college, UCF. Are there any other UCF Knights here today? Yeah, I see some hands. Awesome. Well, Knight or not, I appreciate all of you being here. So, a little bit about my role on Fortnite. Technical UI design is somewhat of a niche role in our industry. So for those of you who don't know, we're basically a bridge between art and engineering. Those disciplines tend to speak different languages, so we translate. We're responsible for UI implementation in Engine, usually using scripting. So that means with Fortnite and Unreal Engine, UMG and Blueprints are where we call home. As the presenter of this talk, it's of course going to be from my perspective as a tech designer. So if you're in a similar role, then great. This is going to be perfect for you. If you're a solo developer or someone who wears many hats, then I think you'll find something to learn here too. And if you're someone who works with tech designers, then this is going to help you learn how to best collaborate with them when building UI. So the first thing we're going to go over is an intro to Viewmodels. So don't worry if you haven't used them yet. They are still a new feature in Unreal Engine. After that, I'll be explaining conversion functions and their uses. Then I'll give recommendations for standards around cleanliness. After that, we'll talk about communicating to the VM as opposed to the VM sending data to the UI. Then a quick look at some quality of life improvements for working with Viewmodels that were just released with Unreal Engine 5.6. And finally, we'll bring it all together with some examples of these things in use. So, what is a view model? We use view models within the MVVM architectural pattern, which stands for Model View, View Model. It allows us to separate out the view or the screen from the data and data source. Previously in Unreal, most teams were binding code directly to specific widget elements. That direct binding method hit limitations of scale. Long-term ramifications weren't really considered when it was proposed as a solution. So Viewmodels aim to solve those problems. It is still technically a beta feature in Unreal, but Fortnite's been using it for a while now, so I'll let you decide your risk tolerance with that in mind. Since it is a beta feature, though, you're going to have to go into the plugins window and turn it on before you'll be able to find and use it in UMG. As a little heads up, you're going to hear me say VM a lot during this talk. Just know that I'm using it as an abbreviation for Viewmodel. So I want you to think of your view model as a pantry. So when you're cooking, you can use the same ingredients to make a number of different meals. So let's say I look at my pantry, and I've got tortillas, chicken, cheese. I can make tacos, quesadillas, or burritos, all using those same ingredients. That same sort of idea is what's great about view models. They provide the data for you to use however you like, without having to ask for any changes from an engineer. So raise your hand if you've ever worked with artists or designers that have seemingly out of nowhere asked you to totally redesign a screen. Yep, probably at least half the room. So maybe they said it's not meeting goals, or it's causing player confusion, or they just don't like how it looks. Well, MVVM can make that redesign process quicker and easier. So let's look at a Fortnite example of the same data being used to create different layouts. With the Big Bang event in Fortnite, we needed to update the locker to support multiple different game modes beyond just Battle Royale, like Rocket Racing and Fortnite Festival. You can see that update to the locker screen on the left side of this video. The way the screen worked at that time was that we were updating the contents on the right side of the screen based on your selection of the side nav on the left. We got a lot of feedback on this iteration of the screen that convinced us to do some pretty major iterations. One of the changes that we made that's most notable for this talk is that we completely changed the UX of how you navigate these sections. So now on the right side of the screen, you can see we are scrolling through all the sections as if it's one big list. We were able to refactor the layout of this screen with little to no engineering support. The before and after may look similar, but the structure of how it's built is actually quite different. So with MVVM, there's no code being tied directly to specific elements in your widget, so you as a designer are free to refactor to your heart's content. So here's another example from Fortnite. This is from the store. On the left is the top-level view of the store, and here in the screenshot, we're displaying large tiles for jam tracks. This is just one section of the store. We also have others for different item types like outfits and Lego sets. At the bottom of the jam tracks section, you can press a button that says View More, and it'll take you to the list view that you see on the right. Setting up that secondary view didn't require any engineering support. All the data already existed in the view model that we used on the left side example, so we use that same VM. So yeah, that means not only can you redesign screens using VMs, but you can also reuse the same VM for multiple different views at the same time. All right, for creating your VM, you can create your view model in Blueprint or C++. You can even have a mix of both of them for different view models. On larger projects like Fortnite, C++ is generally going to be the option you choose, but you do have the option for either. Something that is great about being able to create VMs in Blueprint is that you can prototype without having to wait on engineers to create a VM for you. And then, once the real VM is created, you can switch out the test one later pretty easily. I wanted you to know that these options exist, but in this talk, I'm not going to go any further into the process of creating VMs. Let's instead focus on using them. So there's currently 5 options for getting or creating your VM instance. It's important to understand when to use which option based on your use case and preferences. So the first option is manual, where you set your VM yourself. This can be done through blueprints or binding to another VM that has a VM within it, which I like to call VMception. Create instance is something we don't often use on Fortnite because we generally want a VM that's already populated with data, but you can use that if you want an instance that's specific to the widget that you're in. For global view model collection, you add your VM instance to the collection and then specify the view model identifier by typing in the string to get the one that you want. Next is property path. With property path, you have a couple options to get your VM from elsewhere. The first is to reference a VM that you've already gotten in your widget that has a child VM, and then you can create a path to that child VM. The second is to create or reference a function that will get the VM from another source for you. Resolver is where you use a resolver asset, which is in code in our case on Fortnite, to automatically get or create the VM instance for you. This is generally used when you only have one instance that's going to exist to the VM that's globally shared. Then you're able to get it automatically since you don't have to specify which instance of the VM that you're needing. If you want more detail on any of these options, the QR code on the screen will take you to the official documentation. The 2 creation options that we use the most on Fortnite are manual and resolver. That's because when we want a specific VM, we find that we generally have a good way to get it manually in the context of the widget. And if we want a global VM, then resolver is just the most user-friendly way of getting or creating that instance. All right, now, once you have your VM, you need to bind an element property to a value. Here's an example of a very simple binding. So in this direct binding, we're setting the benefit name's text value to the crew benefit VM's get title string. You can see the result on the tiles. It sets the benefit's name to either 1,000 V-Bucks, Battle Pass, or OG Pass. Each one of these benefits has their own benefit VM with information about that benefit, with title just being one of those. Looking at these tiles, you can probably tell the benefit icon is another one of those variables in that VM. Now, sometimes the way that you want to use your value from the VM is too complicated for just a direct binding. So for this example, I want to set the text on the highlight in the bottom right of these tiles. So you see like that 5 to claim in yellow. I need to take a few things into consideration to do that. First I need to know, is the tile double width, like the one on the left, or single width, like the one on the right? If it's double wide, then I have enough space to add 2 claim after the number. If not, then I just want to use the number itself. The other thing I need to check is if the rewards available is more than 0, because if not, then I don't want to show the highlight at all. The way that I can bind to a VM value while also implementing all this logic is with a custom function. So now you can see I've created a setHighlightText function in the crewPass button widget. That function takes in an integer, which we're getting from a function in the season pass VM that gets the number of purchasable rewards. Then, with that integer, I can do all the crazy logic that I described to determine in blueprints how to display the number of rewards. So when you have a more complex use case for the data that you're getting from your VM, a custom function is a great option. I'll give more examples of when it makes sense to use a custom function or not later in this talk. Now let's talk about a couple of the options that you have when you're setting up your bindings. The first is the directionality of the binding. The first option you have there is one time to widget. One time is a little bit of a misnomer because it can actually change when the VM changes. But as long as the VM stays constant, then the value will only be set once. So it's more like one time per VM. One way to widget is the most common setting that we use here. That's going to send a value from the VM to the widget and update it whenever the value changes on the VM. Two-way and one-way to Viewmodel are rarely used on Fortnite, but an example would be text entry or checkboxes where the user is setting a value on the view, the widget, and we need to send that value back to the VM. The next setting that you have on bindings is around timing. When it's unchecked, this defaults to auto, but you can override with immediate or delayed. The only time I've really had to override here is to choose delayed, because this can sometimes help if you're having race condition issues. All right, now let's talk about conversion functions. Conversion functions are another way that you can set up your bindings, and they're a very handy tool. And thanks to conversion functions, you might not need to create a custom function in your widget like I showed you earlier. There were around 1,250 conversion functions included in Unreal Engine 5.5. Basically, what these functions do is convert one value to a different kind of value. So let's say your data for controlling the visibility of a widget is based on a bool. You can't directly bind a bool to a widget visibility because those are two different types of properties. So then you might think, well, I guess I need to create a custom function in my widget to determine how I want to interpret that bool into a visibility of your choice. But that's not necessary. With a conversion function, you can make that distinction right in the binding. So in this example on the screen, we're using the toVisibility conversion function to translate our bound Boolean value into a visibility. The visibility options that I've set here in the example are static because I always want them to be these states of not hit testable for true and collapsed for false. But if you click that link button next to those visibility states, they could also be variable based on a binding. So there's a lot of options and possibilities there. All right, now I'd like to talk about a common pitfall that I've seen people fall into. The challenge that leads to this pitfall is, what if I need a function with multiple values from the VM at the same time? Right around now, you might be realizing that all the binding examples I've shown you so far only take in a single value. So here's an example of where you might need multiple values at once. In the Fortnite Season Pass reward track screen, we have a status bar that gives you details about how many rewards you have available to claim, tells you if the page is locked, celebrates if the pass is completed, and more. So in order to properly determine what state this status bar shows, we need to compare a few different variables from the VM. Another example where you might need a few variables at the same time would be an inventory screen. If you want to show if an item's equipable or not, you might need to check the items level and the user's level and compare them to see if they meet the requirements for equipping that item. Or imagine a character selection screen. In order to correctly set the state of a character tile, you might need to know if the character's been unlocked yet and if any other player has already selected to play as that character. So let's look at that Fortnite example I was talking about. Let's say I set up the status bar, and oh no, I've run into a bug. You can see that the status bar says locked page in the top left, but the page is actually not locked here. The screenshot on the bottom is showing how it should look, showing 5 to claim. The setup that led to this bug is a common one for people new to Viewmodels trying to use multiple VM values at once. So let's take a look at how it was set up wrong and what the solution is. So here's what we often see. People will bind a function to one of the values that they need. Then they get the other values through blueprint get nodes in the function. The assumption that people make is that since you're getting other values from the same VM, it should be fine. In this example, we want to set the active widget of the visibility switcher and choose that widget based on the past completion state, whether the page is completed, and if the page is locked. So let's zoom in and look a little closer at this function. You can see that the first branch uses the Boolean that's bound in the view binding, is past completed. Since it's bound in the view binding, that value is coming into the function as an input parameter. You can see it coming in on that initial function node, and the F icon on the top right of the is past completed node indicates that it is a function variable. And that's a little tip for you as well if you didn't know. You can also get your input parameters within a graph without having to bring a long string across from the initial function node. All right, for the second branch, we're getting the next value that we need, is page completed, using blueprint get nodes. That value is coming from the same VM as our first bool. However, since it's not coming into the function as an input parameter, we're directly getting whatever value is currently stored on the VM. That seems fine, but you'll see the issue soon. At the bottom here, we're using our final bool, is locked as an index for a select node. Once again, using blueprint get nodes and coming from the same VM. Finally, at the end of the function, we're setting the active widget based on all of those different comparisons that we just made. Okay, so now the problem with this setup is that the function is only going to be called when the past completion changes, because that's the only bound value. These bound functions are only called when the value that they're bound to changes. So that means it won't be called if the page completion changes or the page lock status changes. That can obviously cause bugs, and setups like this have been the source of bugs for us on Fortnite in the past. So even if you're using values that you think should be updated around the same time, even slight variances in timing can cause problems. So be careful not to set up your functions like this, because it can be easy to do on accident even. So the solution. The solution is to make your own custom conversion function. This example takes in all the pieces of data that we need to figure out the active widget. So you can see now in this binding setup, we're binding to all 3 of the bools instead of just 1. So taking a closer look at this new revamped function that goes with it, you can see the bools are being sent in as input parameters instead of using those blueprint get nodes from the VM. Another thing you'll notice here is we're no longer setting the active widget in the function anymore. Instead, we're returning the widget that we want to be the active widget as an output from the conversion function. And I'll explain why that is in a little bit. All right, so looking at the binding again, you can see we bind the returned active widget to the widget switcher's set active widget function. This binding effectively does the same thing that the set active widget blueprint node was doing in our earlier incorrect setup. This new setup with all 3 values bound ensures that all the values are going to trigger this function, this binding, and that all of them are up to date. Conversion functions can be very helpful, but they're also a different mindset than a lot of us are used to. In some situations, you might think you need multiple values at once, but not actually need them to be in the same function. When possible with MVVM, it's best to break out functions that are doing multiple different things into multiple different bindings or functions. It's better for clarity, and it helps to prevent bugs. So coming back to our original example, the reason this incorrect status happened is because when I opened the screen, the page was actually locked. But the page can be unlocked by claiming rewards on previous pages. So I went ahead and I did that. However, once I had unlocked enough previous rewards to unlock this page, the status bar didn't change. It didn't update. That's because it was only bound to the past completion bool. That means only that bool changing is going to call the function at all. And I didn't complete the entire pass. I just completed some earlier pages. So the function wasn't called, and it didn't update. Now that I've bound all the Booleans to the function, it's going to be called when the page lock status changes, therefore updating correctly, like the bottom screenshot. All right, so now you want to create your own custom conversion function. The first step to do that is to set the function detail properties correctly. So you're going to want to set up the inputs that you need and one output. Then the most important part is to check the checkboxes for pure and const. By checking these options, you're creating sort of like a contract that you're not going to alter the state of the widget in this function. Conversion functions are only supposed to calculate and return a value, not make changes to the widget within them. So that's why in that previous example, I switched to returning the active widget that I wanted to set rather than setting it in the function itself. Now, once you've set up your custom conversion function, you need to create the binding. Finding your function can be trickier than you might expect, though. It doesn't show up in the widget category like other functions that you've created in your widget. Instead, it's in the conversion functions category with all those global conversion functions that I told you about. Don't worry, though. Even though it's in this list, it's still only going to show up here in that widget that you created it in. All right, now let's talk about some tips for cleanliness and setting up your UI with MVVM. Every team has their own standards, but I thought it might be helpful if I show you some of ours. So the first thing you can do is to organize your functions into categories. Having them in folders helps to make things clear. There's a Viewmodel default category that you can use, or you can name your own. If you haven't used function categories before, you can find the field in the details panel when selecting your function. You can also scan the QR code on the top right of this slide for the official documentation around this. When it comes to naming conventions, we like to use VM_ for custom functions that we bind to, and CF_ for custom conversion functions. Not only is it good practice to use naming conventions like this, but it'll also make your life easier when you're finding the functions in the long lists when setting up your bindings. All right, I think all of you here already know this, but finding ways to make your functions generic enough to be reusable is hugely beneficial. In game dev, there's always a fine balance between making things bespoke so that they feel special, but also consistent so that you can easily update and maintain your UI. The larger that your UI grows and the longer that you plan to support it, the more important that reusability becomes. Reusing functions within your widget is great, but if you want to go above and beyond, then you can create a blueprint function library. By creating your custom conversion functions in there, you can reuse them across multiple different widgets, and you only have to update in one place if you need to make a change. Most of what we've been talking about so far has been about getting data from the VM and using it in your widget. That is the primary use case. But sometimes you need to communicate from the widget to the VM. So here are the primary methods of doing that. The first is setting a property in Blueprint, which is what we do most often on Fortnite. The next is calling a function in Blueprint if your programmer has set one up for you in your VM. The final method is binding to the VM. As I mentioned earlier, we don't often bind to the VM like this on Fortnite, but it is an option. And so in this example screenshot that I'm showing, we're binding a Boolean of whether or not the terms of use were accepted by the user to a matching bool on the VM. A common use case for widget to VM communication is when we use VMs for tracking selection. On the screen on the right, you can see that we have the Battle Pass tile selected. The title above it and the background are separate widgets, but they also show presentation related to that selected tile of Battle Pass. The VM stores the selection so that these widgets don't have to directly communicate with each other. If you're interested in a deeper look at this topic, I highly recommend checking out Irene Zanin's lab, handling UI navigation using MVVM and Common UI, just a little bit later today. You'll get a chance to try out some of these techniques for yourself. All right, Unreal Engine 5.6 is freshly released and brings with it some excellent quality of life improvements for working with Viewmodels. If you've used Viewmodels in the past, I bet you're going to be excited about these. And if you haven't used them yet, it's just going to make things that much nicer when you do jump in. The first one is the ability to copy and paste bindings. I was dying for this feature, and I am so glad that it's here. If you're setting up multiple similar bindings, this is obviously going to save you time. And when you've got copy and paste, you of course need duplicate, so that's been added as well. Another addition is the ability to right-click a widget in the hierarchy panel and create a widget binding directly from there. Finally, there's now options to expand or collapse all categories or bindings in the View Bindings panel. Now for my final section, let's bring all these learnings together and look at some real examples of how Fortnite uses VMs. Style guides are a common need for UI and a great fit for MVVM. Your VM can store and provide theme data like text, colors, and materials. And you can have different instances of that same VM with different values to easily retheme your UI. We have tiles like this for every type of pass and every season. But there's just one widget for these tiles. And I don't mean one parent widget with children for each different tile, but literally one widget differentiated by the VM data that it's populated with. So the VM provides us with the pass name, the background material, progression color, rewards claimed, and total rewards. And then we take all that data to dynamically style the widget to look different for every pass and every season without needing to make any editor changes to the source widget. So for example, by setting pink as the progression color for the Battle Pass and yellow as the progression color for the OG Pass, in their respective VMs, we can take that color and apply it to the progress bar and the rewards claim text. So let's zoom out now and take a look at an entire screen. This is the Battle Pass reward track screen. And based on the presentation that I've been giving so far, hopefully you know what I'm about to say. It's also the OG Pass reward track screen. And it's the Music Pass screen. And it's the Lego Pass screen. All of these seemingly different screens use the same screen widget with different VM data. The goal when building screens like this is to create a system where artists have the flexibility to make each version of the screen look unique, but keep the logic and the widgets centralized so that polish and bug fixes don't have to be done multiple times in multiple places. In the past, it wouldn't be unusual to find a bug in a screen like this and realize we have another similar screen that's probably got the same bug. So then not only do you have to fix it in multiple different screens, but you have to remember to keep alignment between all those different widgets. Not anymore. All right, so here's kind of a simplified breakdown of this screen. Let's focus on 6 important widgets, all of which use Viewmodels. So the first thing you're going to notice is that we use a variety of different Viewmodels rather than one big one. Figuring out how to split your data into relevant groupings of separate VMs is an important skill that you're going to want to hone. The next thing that you'll notice is that several of these widgets use the same Viewmodels. It's best not to think of VMs as being associated directly with a certain widget. VMs should contain a grouping of related data, which many widgets can then use as they like. One of the VMs that you see being used multiple times here is Season Pass Selection VM. And it's an example of using VMs for tracking selection, like I mentioned earlier. With the VM keeping track of things, widget 6 doesn't have to communicate with widget 4 to tell it that the focused item has already been claimed. The VM tells both of them individually. All right, now let's look inside a couple of these VMs to see what kind of data they have. Season Pass category VM has data related to the pass category. This includes things like the category title, cost per reward, which we can change per category, owned versus total rewards, and more. Notice that all these values make sense to be together. Organizing your VMs into buckets like this is going to make your life easier. On the right, we have the item details VM. This VM provides all sorts of data about the selected item, like its name, description, preview image, and more. While the VM on the left is specific to the feature of season passes, the item details VM is generic enough that we can use it anywhere that we show items. Because of that, we try to keep anything specific to season passes out of that item details VM. So here's an example of that item details VM being used in multiple features. As a reminder, on the left, we're using the item details VM for the item info on the season pass screen, showing Cassidy Quinn. The screen on the right is the offer inspection screen in the item shop. We're using the same VM to get info about Jonesy the First. The item shop doesn't need to know anything about season pass data, so that's why we kept that data out of the item details VM. It would just bloat and add complexity to the VM that we don't want or need in the item shop. So the lines here show the corresponding values being used in both screens. The item type, name, compatible game modes, and item preview icon are all part of that item VM. And while both of these items are outfits, we can use that same VM for storing information about other item types, like vehicles and emotes. Okay, let's review everything we learned today. I told you what view models are and how you can set them up and use them. We talked about when you might need to use custom functions or create your own custom conversion functions. We discussed the importance of organizing your view model work, and I shared some tips about how you can do that. And then finally, I showed you how you can put your VMs to use beyond just standard screen setups, including style guides and selection tracking. I hope you all feel more confident about MVVM and are excited to go build some UI using it. That's the conclusion of my talk today. Thanks all of you for joining me.